Hey everybody, today's lecture is on function transformations. Order matters. Oddly enough, this topic is not usually addressed in most textbooks, which is kind of crazy because it's important. In fact, many times, the first time this comes up is in pre-calculus, in the trigonometry section, when you're doing transformations of trig functions, which is kind of crazy because you needed it way before then. So let's take a look at what most textbooks have to say about function transformations. Here's one textbook's summary of graphing techniques. It addresses vertical and horizontal shifts, vertical and horizontal compression and stretching, and reflections across the x and y axis. And that's very nice, but you'll notice that it doesn't say anything about what you should do when you have more than one transformation of the same graph. So, it does talk about these, but for example, horizontal shifts, it says that if you have f of x minus h, for example, you should shift the graph of f to the right h units. It's not exactly a lie, but it's definitely an oversimplification. So, what do I mean by that? Well, okay. Remember when you were first learning how to multiply binomials? Your math teacher may have told you about a thing called FOIL. And FOIL stands for first, outer, inner, last. And it's this pattern kids are supposed to memorize instead of just distributing. It's this pattern to help them remember how to multiply two binomials. The problem with that? What happens when you have a trinomial? Okay, well, let's try it. I'll do my first two terms, and my outer two terms, and my inner two terms, and my last two terms, and you'll notice that negative 7x never gets to see any action. FOIL totally failed, okay? It works on simple problems. It's an oversimplification. Another example of an oversimplification is when you were first learning to factor quadratics. So let's say you had x squared plus 3x plus 2. And your math teacher may have told you, well, it's really simple to factor this, which of course is true. All you do is you find the factors of your constant that happen to add up to your coefficient of x. And you say, oh boy, gosh, the factors of 2 are 1 and 2, and 1 and 2 add up to 3, and life is happy, and everything is easy. And then somebody gives you a problem like 2x squared plus 5x plus, I can't make up a problem on the fly, but let's pretend that this actually factors, and your world comes to a crashing halt because all of a sudden there's a coefficient on x squared that is not 1. Okay, so these pieces of advice that you're sometimes given, they're not untrue exactly, they just fall apart in more complicated problems. So let's take a look at a slightly more complicated transformation. Also, I want to point out that if you have transformations that affect your x values and transformations that affect your y values, that's okay. They don't interact with each other. Like you could do all of your x transformations and then do your y transformations, or all of your y transformations and then do your x transformations. They're not going to mess with each other. It's when you have two transformations that affect the same variable that you have to worry about which to do first. So let's look at, for example, y equals 2x plus 4 quantity squared. Okay, the parent function is y equals x squared. And according to the advice given by our textbook, this 2 means that we are going to, it's inside, so it's affecting our x values, and x values, of course, are crazy and backwards, so instead of stretching it, this is going to compress our x values by a factor of 2. So horizontal compression by 2. And also according to our textbook, this is going to shift our graph to the left 4 places. Great. So, what would it look like? Well, it depends on what order I do things in. So let's try compress, then shift, and let's try to shift and then compress. Okay, so y equals x squared starts out, I'm going to just move the vertex. Y equals x squared starts out at 0, 0. Well, compressing it doesn't do anything, and then I scoot it over 4. So the vertex is here. Another point would be, let's say 2, 4. Okay, 2, 4 is on the graph y equals x squared. Now if I compress it horizontally, in half basically, so now I'm at 1, 4, and then I scoot it over 4, so now I'm at negative 3, 4. Another point that's on this graph would be negative 2, 4. When I compress it, I'm at negative 1, 4, and then I scoot it over 4, 1, 2, 3, 4, I'm at negative 5, 4. Ooh, I totally missed my dot. Pretend that's a lovely U parabola shape, okay? And again, this vertex is at negative 4, 0. Okay, now let's shift it and then compress it. Okay, starting at 0, 0, if I shift it over 4, 1, 2, 3, 4, and then I compress it, so from 4 I cut that in half, and now I'm at 2, 0. Or I'm sorry, negative 2, 0. Interesting. Another point on my graph would be 2, 4. If I shift it, I'm at negative 2, 4, and then I compress, so I cut the x value in half, and now I'm at negative 1, 4. Another point that would be on my graph would be negative 2, 4. If I shift it 4 to the left, now I'm at negative 6, 4. Cut that in half, I'm at negative 3, 4. And so I have a skinny parabola whose vertex is at negative 2, 0. Well, these are different, right? Obviously, I don't get the same thing. And if I'm obeying what I think the book is saying, it should be the one where I end up at negative 4, 0. Well, one way I could solve this debate would be to graph it on a graphing calculator because, you know, in theory the graphing calculator knows the order in which this should be done. In fact, the graphing calculator is going to do it point by point. So the graphing calculator is making a giant super T-chart and plotting every single x value, well, not every single one, but it's plotting a lot of points. And that's how it gets the numbers. So the graphing calculator is going to get the right thing. So let me show you what a graphing calculator gives us. So let's graph the equation y equals 2x plus 4 quantity squared. Oh, look at that. The vertex is at negative 2, 0, not negative 4, 0. So what happened? I thought that the book told me that if there's a plus 4 here, I'm supposed to scoot my function 4 places to the left, when in fact it only ends up scooted 2 places to the left. Well, okay. It's weird. Normally you would follow the order of operations, and so that's why with your y values, first you do the stretch because it would be a multiplication, and then you would, or shrink, and then you would shift up or down because multiplication comes before addition. But everything inside of the x values, or inside the function affecting the x values, is backwards, and so you would do the addition before the stretching or shrinking. Maybe that's one way to look at it, and if that works for you, that's great. Let me give you a step-by-step that might be a little simpler. what you should do with any function that has a coefficient, a multiple of your x, is go ahead and a horizontal translation. Go ahead and factor out that multiple. So 2 times x is 2x, 2 times what is 4? 2 times 2 is 4. Okay, 2x plus 4. Cool, cool. Now, this 2, this is the amount that our function is shifted to the left. Okay? The advice in the book works as long as you factor out the coefficient of x. So, let me make a list. Factor out any coefficient of x. Now that you have that coefficient factored, go ahead and stretch or compress then shift. Okay? So, that applies for both x and y. Don't factor y. But if x has a coefficient, factor it out, and then stretch or compress as required. If this is a fraction, you're going to be stretching. And then go ahead and shift. So what would this look like for this function? Well, we've already factored it. So y equals 2 times the quantity x plus 2 all squared means that first we're going to horizontally compress our x by 2, or cut it in half. Remember, x's are backwards, and we're going to scoot left 2 places. Wow, it would be nice if I could draw a straight line. Oh well. Alright, so normally we go 0, 0, 1, 1, 2, 4. And then I'm going to switch colors. So every point, the x value gets compressed. That means like cut in half, but 0 cut in half is nothing. It's still 0, and then back 2. Here, 1 cut in half is a half, and then back 2, so we're at, okay, there. 2 cut in half is 1, back 2 puts us at -1. And let's see, -1 cut in half is -1/2, back 2, -1.5, -2.5. 2 cut in half is 1, back 2 is -2, -3. And so we have our new function, which is, the vertex is at -2, 0, as it was supposed to be, and it is now skinny because it is being compressed by a factor of 2.